So what is system structure? System structure is used to partition the task into small components, which we can also call as module, rather than having one single system, that is monolithic system. So while partitioning, we will clearly define what are the inputs, outputs, and function that module needs to be performed in the system. A modern operating system is very large and complex, so it's necessary and we have to be very much careful in designing the system. The basic concept of the operating system is to act as an interface between the user and application program and the hardware. So it needs to be designed very carefully. So what are the types of system structure? There are five types of system structure. First comes a simple structure. It is also called as monolithic structure. And the second is layered approach. And third one is microkernel. And comes modules. And finally, hybrid system. In this lecture, we are going to see about one by one. So first, let's see simple structure. The example for simple structure is MS-DOS. In this, it's not a well-defined structure. It's very small and very simple, but it cannot perform a more efficient task. So as you can see, it's less efficient and it's not modular also. All application program are able to access the RAM BIOS device driver, which makes it vulnerable. Any layer can access the RAM BIOS, which is not safe. And we cannot be rewrite that also because it is written in Intel 8088. Which doesn't provide any dual mode and also no hardware protection is possible. In MS-DOS, the interfaces on the levels of the functionality are not well separated. That's the major drawback in this approach. So let's go to the major disadvantages of this approach. As I said earlier, it's a security problem. So let's go to the next approach. Layered approach. As the name suggests, it consists of layers. The innermost layer is called as layer 0 and the topmost layer is called as layer n. So there are usually 6 layers as you can see here. Layer 0 indicates hardware and up to layer n. Layer n shows the user interface part. So here the OS is broken into the number of layers to make it modular. In previous approach it is not modular to but here it is modular. Each layer uses the function and the services of the layer that is below to it. For example, user program can access the layer below to it, buffering for IO devices. So likewise, layer 4 can access the services of layer 3. So it's necessary to um, identify and classify the layers and to build it properly. What are the major advantages? It's very simple to construct and also to debug. If a particular layer has some error, we can just debug that particular layer. That's enough. So what are the disadvantages? It's very less efficient in terms of system call because if a user program wants to access the device driver, it needs to call to the buffer for IO devices and then to the device driver. So it takes the system call takes overhead. That's a major drawback. Let's go to the next step, microkernels. As the name suggests, micro means small, as we all know. Microkernel means small kernels. To provide the communication between the client program and the various services that are running in the user space. Uh, so first let me explain this. There is two system mode. One is user mode and another one is kernel mode. Our application program will run on user mode, and kernel mode has some high privilege. Um, so OS will reside on kernel mode. If application program like MS Word, if it fails, so it only that program will alone will fail, not the entire system. So if the program in the kernel mode fails, the entire system will crash. So microkernel is a term. It's the smallest kernel that will process the activities of the actual kernel, but with the minimal process and memory management techniques. What are the advantages of microkernels? It's very secure and reliable. We can trust that services and it's very highly secure. And here comes modules. What is modules? Modules or loadable kernel modules. Kernel has a set of core components, that is in center there will be a kernel, and its services or separated as a modules, either at boot time or during runtime we can run it. So what is the key idea in this? Kernel to provide the core services to other services that can be implemented dynamically while the kernel is actually running behind. So the advantage is it's more flexible because that is a layered system. We can module and call any other module. And it's more efficient because as modules do not need to invoke the message passing in order to communicate. So in order to communicate between upper and lower modules, there is uh, no need to invoke the message passing. So it's very efficient. So let's see its example. The example of modules is Solaris OS structure. As you can see, the core Solaris kernel is in the center. It can access the every module. So these are the 7 types of loadable kernel modules. So from scheduling classes, file system, loadable system calls, likewise up to the device and bus drivers. So what is hybrid system? Hybrid system is a combination of any system that we have discussed earlier. Maybe is a combination of modules and simple structure is a combination of any two structure. So it's a combined, when combine the different structures, we will result in hybrid system. So this will address the performance and security and usability issues that we have seen in the previous modules. Because in the previous types, there is some issues in every module, but the best out of every module is combined and added to make a hybrid system. So the common example of the hybrid system for in desktop version is Mac OS. In the two most common example for the mobile operating system is iOS and Android. These are the two most common examples for the hybrid system. These are all about the system structure and its types. I hope you all understood. Thank you so much. If you have any queries, you can comment below. Thank you.